So everyone, we're going to be looking at some communication skills that you'll need in maths or probability, but we're also going to do a few questions to help you better understand the notation and what symbols represent. So this here is the general rule for probability. This states that the probability of A is equal to the number of A's divided by the number in the sample space. So if I was to roll a dice, the probability of getting a 6 on a 6-sided dice is equal to the number of 6s divided by the amount of numbers in the sample space. The amount of numbers in the sample space. Right? As I said, you've been doing this all along. You know that the probability of rolling a 6 on a 6-sided dice is 1 on 6, and that's because there's 1 6, and there is 6 numbers on a dice. 1, 2, 3, 4, 5, and 6. So the bottom number would be a 6 because there's 6 things in the sample space. If I was to write the sample space out, it would just be 1, 2, 3, 4, 5, and 6. So you can see the number of 6s is just 1, and the number of things in the sample space is 6. So this is what this represents. The next thing you're going to need to know is this thing called complementary events. So complementary events add up to 1. So using the example before, the probability of getting a 6, 1 on 6, plus the probability of not getting a 6. So we do that with 6 dash, because that's 6, not 6. You can also write it as 6 line. So they're the two ways of writing not 6. Plus 5 on 6, because the chances of not getting a 6 is 5 on 6. So that's equal to 6 on 6, which is equal to 1. So these two events are complementary because they add to 1. We can use the formula A, probability of A, plus the probability of not A is equal to 1 in a large number of different situations. However, what you will find is normally you will have to use the reverse or the inverse operation of this formula, and you might have to solve for A or you might have to solve for A dash. So we're going to rearrange this formula to solve for A. So we're going to minus A dash on both sides. We're going to do PR of A equal to 1 minus PR of A dash. So this you will use more so than this formula up here, because normally you're given a probability of A or the probability of A dash, and you can rearrange and solve for the one that you don't know. We're going to be using Venn diagrams and this idea of intersections and unions. Now, an intersection is where two things meet, and like this in the middle, and the union, which is two things combined. So when we have an intersection, we write this upside down curve, kind of looks like an N, represent it's in both A and B. And when we are looking at both circles, we use the union. So circle of A, but also with circle of B, would give us this whole region here. Not A represents everything that's outside of A, and not A and B, so the union of not A and not B is just that region on the outside, because we want not A and not B. Over here, this will be a little bit new. So this over here, you might have been calling this the just A part of the circle. So this here is the intersection between A and not B. So what this says is we want circle A and not circle B. So we've actually gotten rid of all of B. So that's what this represents. Now here we have the intersection of not A, so we don't want A, and B. So we're just left with this section over here. So we can almost scribble out A, and we're just left with this part of B here. Now, there is a very important formula for this part of the unit, and this is the union formula. So when we're looking at Venn diagrams, we have our two circles, and we have the bit that laps over in the middle. So I might have 4, 1, and 6. So in circle A, the probability of circle A would be equal to 5 out of 11. The probability of circle B would be 7 out of 11. Now what I just said before, the union, so we want A and B, so the probability of the union of A and B would be, we want circle A, and we also want the probability of circle B. Now if we add these two probabilities together, we end up with 12 out of 11. Now immediately, that should get you to question this, because we can't have more than 1 as a probability. So what this means is, and you might have already noticed, that we've counted some numbers more than once. We've counted the 1 in the middle twice. So when we worked out the probability of A, we did 4 and 1. And when we worked out the probability of B, we did 6 and 1. So we've counted the 1 twice. So this formula is not quite complete yet. We also need to add to it minus the probability A intersecting with B. So the probability of picking the intersection of A and B is 1 out of 11. So we're going to add our minus 1 over 11. So this now equals 11 out of 11 is equal to 1. And that makes sense because we don't have any numbers anywhere else. So the probability of picking something that's in A or B should be 100% or 1. So when two circles overlap and there's some numbers that we end up counting twice, or can be in both the probability of A and the probability of B, we have to use this formula. PR of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection of A and B. This formula is used when the circles are overlapped and they are what is called not mutually exclusive. So, not mutually exclusive means that they can occur at the same time, which is this thing in the middle. However, in the circumstances that events are mutually exclusive, that means they can't happen at the same time. So the two circles are going to be separate because you can't get anything in A and B at the same time because they're separate. So this then means that we don't need to add this thing on the end. But if you did add the thing on the end, it's not going to make any difference to the formula because this will just be 0 because you can't get anything with the intersection of A and B in this formula. So this would just end up being, if it is mutually exclusive, PR of A plus the PR of B minus 0. So that's why this formula here doesn't have the union, it's the intersect of A and B in it. Let's scroll down and do a question on filling out a probability table, or a two-way table.